Next, we're going to look at a vertical shift. So a vertical shift is going to move our function up and down. Kind of talked about this a little bit already. It's not going to be too difficult. It's just whatever we're going to call the equation of the midline, which will then affect our amplitude just a little bit. So I have one problem that we're going to look at. Sine and cosine really deal with the same thing when it comes to the vertical shift. So I'll just do one that deals with cosine. So we need to find the amplitude, period, and then the vertical shift. The equation of the midline is really kind of the same thing as a vertical shift, so I'm not going to write the equation of the midline at all. So to start with, our amplitude, remember that is the value out in front. So our amplitude is going to be 1/2. Our period, again, is right after the cosine function, which in this case is 1 again. So we're going to take 360 divided by 1, which is 360. And then our vertical shift comes from the value of -2. Remember, we follow our intuition this time, so our vertical shift is -2. When we graph, we're going to start with the midline. Think of shifting our function down -2. This middle line here is not the x-axis anymore. Okay, our midline this time is going to be at y equals -2. So I'm going to label this as a -2. And now our amplitude, we're going to say we're going to go up 1/2 from -2 and down 1/2. So if I take -2 plus 1/2, that's going to get us -1.5. And then if I take -2 and subtract 1/2, that would get me -2.5. Okay, that's the difference when we're dealing with a vertical shift now. We're no longer at y equals 0 for the equation of our midline. We're now at whatever our vertical shift was. In this case, we moved down 2. Then we can find the locations that we normally have. So we didn't shift left or right at all. So we're going to start at -2, comma, -1.5. We're going to start at that location. So then we're going to find our next location, which is based off of our period. So we're going to move over 360 degrees. And then our second location is going to be at 720 degrees. Again, we're dealing with cosine, so I like to find that middle ground. So we're going to take 0 plus 360 and divide it by 2. That's at 180. And then we can do the same thing over here, 360 plus 720 divided by 2. And then that will get us 540 degrees. Now we can start plotting some of our locations. So cosine, again, we're dealing with a cosine function. We normally start up at the top, so we're going to start up here at -1.5. Our first location, our first cycle ends at 360, and our second cycle ends at 720. At halfway, we should be down at the bottom. And at 540, that was half of our second cycle, we should be down at the bottom as well. Here would be what your cosine function would look like. Again, you can find these locations in here if you'd like. This would be a quarter of your cycle, or a quarter of 360 would be 90 degrees. This would be at 3/4, which would be at 270. And then you could take 90 plus 360 to find this value, which would be 450. And then you could do the same thing here. You could take 270 plus 360, which would get you 630 for those intercepts.